Hi, I am Sidharth Ramesh, and the founder and CEO of Medblocks. You might know me from YouTube, you might know me from LinkedIn. We've been building health IT solutions for like more than 7 years. And this talk is going to be maybe slightly controversial at an open air conference, but I'm going to talk about why the way we probably do OpenAir today is maybe like something that we should question about and ask ourselves just on the technical side. So again, just a raise of hands, like how many of you here are technical, like developers? Okay, good amount. And how many are like clinicians? All right, good. So from the clinical perspective, this is more or less going to be like, it's everything that OpenAir stands for. It's a talk from the technical perspective, right? So you're going to have, we already showed a lot of demos. There might have been like other people who showed some of our stuff before as well. But I'll tell you my story and how I got started, right? So I'm a doctor by training. And in India, this usually happens when you have both your parents as doctors, then that's usually your only option. So after I graduated from medical school, I had to do this rotation in my hospital in the college. That's me with a mosquito bat sitting in the operating theater doing like super essential work. And I show this because like when I was doing things, right, they made interns do the most stupid things, right? Like they'll ask us to just swat flies so that the fly doesn't come into the theater. They'll ask us to copy records from one system manually into another and do this for like hundreds of patients per day. So I actually got really interested in programming because of this, because they made me copy like lab reports from the lab application into the EMR every day. So I learned how to program, I learned how to script, and then I like wrote a program that worked. But then later on, the hospital said it was a security vulnerability, so they removed it anyway. But one thing led to another, and both my parents have their own ophthalmology site. They have close to 500 patients a day. And the first proper implementation of an EHR that I built was for my own parents. And till today, like I'm pretty proud that that actually worked. And if you see our booth, like we are big believers in you being able to own what you built. Like what I did for my parents, we just now do for a lot more people. We basically build your custom EHR, and we make it easy for anyone to build their own custom EHR. There's a lot of open source bits that we've contributed as well. So overall now, we're quite big, like we're growing pretty fast. Like we have helped a bunch of governments, like big enterprises, startups. These are like super interesting to usually work with. But the main place where I have a lot of feedback about where OpenAir is going and what people think about OpenAir is the training that we do. Like although training as Medblocks, it's not our main revenue generator. We focus like 10 times more effort into like training and the education side, just because a lot more people need to know that this exists. And just hearing from them is like, I think many of you are probably here. Some of you might have taken our courses. But this is also where I learned that there is a huge gap in the way that we do things with OpenAir. Okay, so this is where the controversial bit starts, but I know a lot of my colleagues are here armed with a lot of questions, so I'll leave some time out for questions as well. So the first thing that I got questioned on is, okay, like I have my Django app, like it's a Python framework. I have all of my data in this app. How do I just like integrate with OpenAir, right? And then somebody asked me, like, I've done this thing in AWS QuickSight. I know how to write the SQL queries. Like, how do I really work with what you are teaching us? Like, how do I really integrate with OpenAir? Then this comes so much that I don't even know what Microsoft is doing. But every other week, we have someone ask us, how do I make OpenAir work with Microsoft Power Apps? I have no idea what Microsoft has done. Like, how many of you are like full Microsoft shops here? Like, good amount, okay. AWS? What do the others do? Google Cloud? Okay. And another thing that I noticed was like, especially with templates and openEHR templates, once you create a template, there is this notion that that's like permanent, and you just create compositions for that template, and then you just create a new template whenever there are changes. And then like data is for life, and then you need to keep that data in that repository for life. But how do you deal with that, right? Like, what do you really do to deal with that data? Like, does your AQL keep growing? Does your query, as the years go by, have to be more and more complex? Because now you have to say, okay, data from here, data from that archetype, data from this archetype. And this actually happened to us in production once, where one of our colleagues accidentally used the Pulse V1 archetype instead of V2. And all of our queries were written with V2, and we didn't account for the fact that they had actually created this template long back with V1. So those pulse rates didn't show up in any of the results. So how do I move my data? Like, once there is a new composition or once there is a new template? These are like unanswered questions. And I really think there is this concept of a tech frontier, okay? So a lot of people I've talked to have told me like, okay, maybe openEHR just needs a little bit more time. It needs a little bit more funding and investment, and then the tools will get there, right? Like, we've been part of this journey too. We've, in fact, you know, you have the CKM, you have the archetype designer, and the openEHR tech frontier is definitely growing. We even contributed back to like Medblocks UI, OpenFire, all of these are our projects. But then the standard technology frontier, which a regular developer is familiar with, grows even faster. Then there is so much more now. Like, there is like, okay, how do I do GraphQL on top of this? How do I, you know, Vercel V0 comes up with a way that anyone can prompt something and get an application built. Lovable is doing the same thing. And it already works with standard web technology. Like, how do I get that with openEHR? I keep getting asked this question from so many people. And again, like, we also teach people Fire. Okay, so I know that this is a problem with Fire as well. I think the Fire technology frontier is there in the same fashion, but the real problem here is you have tech investment in proportion to how much a market is able to spend on tech, right? Like, so for example, if you look at big tech, usually their margins are around 60%, and some companies are insane. They're like 80% margins, 90% margins. If you take a look at banking, they're like 10%. They're able to spend that on operational stuff. Hospitals and healthcare runs on like 2% margins, sometimes even like 1%, 0 point something. So healthcare in general does not have that much money to spend. And many of you might already realize this working with customers. Many of you might be developers who are in healthcare, who you for sure would probably be paid a lot more if you just exit healthcare and go to another, I don't know, telecom or banking, or your colleagues are making a lot more, but healthcare doesn't pay you enough. The reason is because we don't have that much money. Yep. This is also where I started getting into the depth about like data platforms in general. Like, this is an super essential book if you are a practitioner of anything to do with data and you're in the industry, you're working with data and data platforms. A data platform needs to be reliable. It needs to be scalable. It needs to be maintainable, right? And this book by Martin Kleppmann, like it's superb. It goes into the details about what this means. But I'll just try to break down a few things on just the essentials. And this has nothing to do with openEHR, Fire. It has nothing to do with anything. It's just how do you deal with data? How do you deal with data systems, right? So what do I mean by reliable? So your data should be resilient to data anomalies, okay? So what does this mean? So for example, if you have data that you insert in a row, for example, and then you have some information that is associated. So for example, you have a student course table here, there is an instructor. So if, for example, you represent it like this and you have the instructor as like Dr. Smith, and then Dr. Smith changes to something else, and you just update one place, that's not enough. That's called an update anomaly. And this is why in relational databases you usually have foreign keys, and then you reference things. Can anyone think of anomalies in openEHR already? Like maybe you've done this using openEHR compositions, but then the principles are pretty much the same. You have the same issues with insert anomalies. You cannot add something, but again, we are doing this all the time with Fire, with openEHR, with all of these systems. But we have a solution to this. Like people have been studying data systems for years. It's been like 50, 80 years that people have been studying this, and we know how to eliminate these issues. We normalize in a certain way. So there are different levels of normalization. But then I don't see people in the openEHR community talking about this enough, right? So what about transaction anomalies? So this is, again, like a super insidious thing that most people don't even recognize. But then let's say you have data in a database, and then you need to write code that basically books a doctor to a particular room, right? What happens if multiple people are trying to do this at the same time? So this is why you need the guarantees of transactions. So what happens here, again, like this might look like a complicated diagram, but to simplify things, if your data system does not know about transactions, you can have this double booking problem. And again, this is one example of this problem. There are hundreds of such examples when, again, this goes super unnoticed until someone notices it one day and then everything breaks, right? So this is called a write skew. There are so many other kinds of data problems. There is read skew, there is phantom reads, there's a bunch of these things. But essentially, if you have multiple people operating on the same system, a REST API is not enough, especially if you're using that as the data platform. And like databases have done this for a very long time, and like you need to be resistant to these transaction anomalies. Scalable. You need to prove that you can scale with today's hardware, right? And we can't keep throwing compute at it in order to get more and more. Like I'm seeing this so much with almost everyone that I know who's implemented openEHR or Fire sort of just uses that JSON-B feature of their database, like of their favorite database. And what usually happens is that you get serious performance hits when you start scaling, right? When you hit a certain threshold, and usually I've noticed that this threshold is close to 3 million. Once you get like more than 3 million, like your standard database doesn't work that well, and then people just start panicking and like throwing more and more money at it. Again, like the cost to run has to scale, right? Like we need to be able to at least sublinearly graph as we are growing, how much does the cost to run this grow? And this is, to me, the most important, which is you need to have talent that's available to work on a particular platform. So if you put out a job posting for an openEHR engineer today or like a Fire engineer, you're probably going to get like us or like, you know. So it's good for people like us, like it's good for our business. But then as an open platform, what happens is all of our clients, every single person, anytime they want something, they have to come back to us. And I don't think that's open in the true sense, right? Like if you are able to hire anyone on the market for the right amount, and then they're able to come in and they're able to build something for you, that is what true open platform means to me. Yep. And again, this includes LLMs now. Like if an LLM, or like if you are able to code something really well with Cursor, but you're not able to do that with, because you have openEHR in the system, then that is a problem, because the developer's productivity now is at least 2 to 10x, depending on like maybe sometimes 0.5x with some people who don't know how to use these AI tools. But we are seeing a massive increase in how productive developers can be if the AI tooling works with the software that they're working on. So this also has like a reinforcing impact, because I've seen so many people switch to React now because AI works well with React, and because AI works well with React, you have more data going out into the open that's React, and then AI gets better at React. So there is a self-fulfilling loop here. Yep. Maintainable. You need to be able to evolve data, right? Like, so you need to think about what happens when I change the pulse rate from one version to another. How do I move this data so that there is one single source of truth for pulse rate? We haven't answered this question yet. And again, this is not unanswered in the rest of the industry. They have very traditional ways to do this, right? Like SQL migrations. And it needs to be simple. And again, I don't mean simple in the notion of easy. Again, there's a really great talk by Rich Hickey on simple made easy. But then if you're a small to medium-sized hospital, you can usually get away with an architecture that looks like this, right? You can just have one application that talks to one database. You can work with that. But every single institute does not need to deploy a full AWS chart, which is a kilometer long, right? And it's cognitive complexity. So if somebody has to think about 20 different services before they even start touching code, that's something that you don't want, because then you can't operate that system easily, right? So you can't maintain that easily. You need to always juggle all of this, and everything becomes more expensive. So operable is, again, you need to be able to back up things pretty easily. You need to be able to patch things up, updates. All of this should be simple. And the simpler the system, the more operable it is, usually. The more stateful systems you have in your system, no, it's going to be pretty complex. So I want to take the standard benchmark that almost everybody has today, which is the SQL database, right? How many of you are using a NoSQL database here in production today? Okay, couple of hands. How many of you are using, yeah, the MongoDB guys, yeah, cool. Okay, SQL database in production. Majority of you, yep. So I think the SQL database is more or less the standard against which almost everything else is compared to, right? So there is this excellent paper by Michael Stonebreaker which talks about, he compares 50 years of database technology. So goes through the hierarchical model, the network model, the object-related databases. And this was, again, published in the 1990s. And basically the conclusion was that, hey, we have all of these new technologies, but nothing really comes close to the relational model, and just SQL, right? And they did the same thing again. The name of the previous paper was What Goes Around Comes Around. This one is What Goes Around Comes Round and Round. And they compared all of the new advancements that we have in technology in the next 20 years. So you had the MapReduce system, the key value pairs, the document stores. And I really urge you to read this paper if you haven't already. They really break it down in as simple terms as possible, what are the problems with these different systems. And the conclusion here was basically still nothing comes close to SQL. The relational model is really good at the three things that I mentioned, being maintainable, being scalable, being reliable, that none of these other things okay, how do you move data once it's in a NoSQL system? You don't. You make changes to the application level so that you are able to handle version 1, version 2, version 3. I know there are people with the MongoDB side, but hi. Questions later for sure. That's okay. But, and I think, again, I know Tom is here, everyone's here. I think openEHR was created 20 years ago. And when the abstractions were made, and when what is possible at the database and what is really possible at the information model, what is possible at the reference model, when all of this was made, these decisions were made 20 years ago, more or less. And we haven't really broken those molds yet, okay? And I think a lot of the reason why openEHR is the way it is and how it's built reflects database capability of 20 years ago, okay? And again, this is what a usual openEHR service looks like, because it's architected based on that. So you have an application, but then you have a CDR that has a bunch of different things. It needs to receive artifacts from outside, and then everybody has to finally implement that on a database. And what do most people in production today use? They use Postgres. I know that most openEHR implementations are on Postgres using the JSON-B feature, okay? Just because of that one thing. But SQL is not the same, right? SQL has grown so much over the years. And in fact, there's this excellent article by the amazing CTO. It just says you know what, you can just use Postgres for everything now. You don't need Redis, you don't need all of these different things. For the majority of your use cases, you can get away with just having one SQL database. And this has actually had an even bigger movement in the past 4 to 5 years. Like there's a company called Superbase, there's a company called Hasura. All of these people are moving just not only from just SQL, but then automatically generating APIs based on what you have in SQL. So all you need to worry about is the database, and then all of your APIs are generated automatically. And again, this is happening now because like we have a lot of wire protocol native applications as well. Like so Postgres is not just a database anymore, like it's almost a standard, right? Like a lot of people are implementing that as the wire protocol for their database. Like if you take Google Cloud Spanner, of course, it's not a Postgres database, but then it has Postgres wire compatibility, right? And then RLS happened, row-level security, right? So with row-level security, what you're able to do is you can, at the database layer, declare who has access to what in SQL. And this, for me, changes the game completely, right? So what you are now able to do is you can actually define an authorization model in SQL. And no matter who has access to the database, you can only do what they actually have access to. Like, and it's super strong security. This is the difference between like deep security and strong, like superficial security, where superficial security is like at the application level, you have different screens that different people are assigned to, and they can only do what they can, like on that application. But deep security is when you move that downwards, right? Like as soon as you move that to the database layer, you can give them an access to a database and they still can't do what you don't like them to do. And this is super powerful because now we have AI, right? Like you don't just have people using apps. You have agents that are working with people to get things done. So this is more important than ever, and then like SQL is already like solving that. What else has happened? How many of you know about Apache Iceberg? Yep. So an open table format, it's an open table vendor neutral format for analytics databases. So what they do is, if you're able to send data in this particular format to any cloud provider of your choice, all of their analytical tools and all of that will just work out of the box. You don't need to do anything more. And this is also based on normal flat SQL tables. So what are we seeing? And like DuckDB is again a superb innovation when it comes to just running extremely large queries just on your own machine. Like this is a lot of tech advancement that's happened. But then what we are seeing now is you may not even need a separate transactional and an analytical system anymore. With these kind of technologies, you might just be seeing everything merge back into one. You can potentially have the best of transactional systems and analytical systems together in one. And we're seeing this in other places as well. Like Fire has been working a lot with SQL on Fire. They've been like pushing data out from Fire into like SQL materializations. But I think that's not the best way to think about this problem, because again, we are building a health data platform, right? So we do need maximal models. We do need the data platform, but we also need to satisfy the criteria of a normal data platform. Even if you're not building for healthcare at all, you should be reliable, you should be scalable, you should be maintainable, right? So the question that I'm trying to ask here is basically like, okay, this is openEHR 20 years ago. This is the only model that was available. But with new database technology, can we do this? Can we move all of the different definitions that openEHR has? Can we move the idea of openEHR into the database? So can openEHR just be SQL tables? That's basically what I asked. And I've also posted this on Discourse like a few weeks ago, so I know a lot of my colleagues are armed with a lot of arguments against me, but it's good. So I'll show you like a quick work demo of like what we've done so far and where we are at. Can you see my screen? Yeah? I think it's visible. Okay. So the first thing is, yeah, we basically took all of the CKM data types and we made them into SQL tables, okay? And this was significant effort. We actually had to even think a lot about, is this the right way to model something? So for example, systolic blood pressure and diastolic blood pressure together actually form pulse pressure, right? So this is like a computed value. What does it mean for there to be data point in the system which has systolic and diastolic, which is not equal to the pulse pressure? Like, so this is a data anomaly, right? So there are a bunch of things, but this was significant work that we have been doing. It's still a private repo, but we do plan to publicly like open source this soon. And another thing that we were able to discover is that you can do terminology validation pretty damn well using just a simple database. You don't need another service that does terminology. You are just able to do everything within just Postgres, and all you need is like foreign keys, and it actually, the performance is excellent. It does a really good job here. And okay, let me show you what something like this looks like. So again, I have with me an EHR that we had built. And another thing that we've noticed is that most of the time, doctors don't tend to think in just structured data. They actually want some free text. They want to type something, and then they want to have some structured data, right? So I think we kind of thought about that into the data model as well. So let me just save this. Let me see what that looks like. So again, we have a blood pressure table, and again, this is the schema. We have all of this in, this is just dbeaver is another tool that you can use to like just connect to a database. And yeah, it's simple, flat tables, like, and everything is like a simple flat table. If you want to see the ER diagram, I mean, it's quite complex, but then I actually think openEHR has done two things really well, right? So one is the maximal modeling, which is if you have something like blood pressure or if you have something like pulse rate, what is the best way to represent all of the fields here? The second thing is two-level modeling, where you can have different archetypes, but then you use them in different ways, and then you combine them in different ways. And honestly, we were able to just model all of those requirements in SQL. And instead of like AQL, we are just able to write SQL queries that did almost like 90% of what AQL is supposed to do. And in fact, I think even more, because there are only some dialects of AQL that are like supported, and you can't do everything today with AQL, but we were able to do quite a lot with just SQL. And again, I think the other thing I want to show you is how easy it was for us to build other tools and dashboards on top of it. So because everything is already in SQL, and then we are able to like quickly move from one tool to another. Like again, I didn't build dbeaver. I did not have to build like a visualizer for my data. This was by someone else. If it were openEHR, then that had to be its own app. But then I come here, this is a visualization tool, QuickSight from AWS, just works. Like I don't have to do anything. Like this is a dashboard of patients who are probably at risk of, like because of diabetes. They already have diabetes and their blood pressure is kind of high. So you may want to reach out to them and ask them like, what's up? Why are they not maintaining their blood pressure? And I could do this with AI. I could do this with a team who just knows some basic SQL and some BI. I don't need them to learn AQL. I don't need them to learn anything. And again, I'll come back to my presentation. All I want to do is get here, okay? Like I don't want to make enemies here today, but all I really want to do is get us to the normal tech frontier, right? Like the standard technology frontier. Because there is so much benefit in doing that. If you don't have to build something custom for everything that you have to do. Like, yeah, it surely maybe takes away some business from people like me, or like people like who are building something just openEHR specific. But then you just open up this idea to so many more people, right? And then what we were able to do is also put this in as a integration hub. Because SQL is already so good at integrating, and basically any tool that you can think of will have an integration that just works with SQL. So we were able to map almost all of this back to openEHR, or FHIR, or OMOP, or whatever you name it, right? But then we have all of our data in our database. We have proper ways to move this data around. There are extremely good mechanisms to snapshot and like take this data out, change the schema. There is only one version of truth. And again, like this is not something that I am inventing right now. It's like this is the standard for the last, I don't know how many years, but like 50 years at least. So all I'm trying to do is, can we get here? Because if we keep building our own stuff, if we keep building our own tools, then the standard industry frontier is just going to move ahead of us, right? But if we move from here into something like SQL and then we just piggyback on top of someone, then we don't need to reinvent half of the things that we are doing right now. And yeah, that's my talk. That's about it. Thoughts, and I know there's going to be a lot of questions, but yeah.
Thank you very much, Sidharth. If there are any questions, just raise your hand. I'm happy to come over with the mic. Corey?
Yeah. I can definitely understand why you get all the negative energy doing this, but thank you very much. I think this is really enlightening. I think the very reason that openEHR and FHIR kind of existed is to be able to manage kind of non-atomic nested kind of array type of data within archetypes or resources. So for example, for a data in an archetype like a history which repeats itself, do you keep on creating more linked tables and kind of going all the way to that level? And how do you manage the complexity of so many tables?
Yeah. So I really don't think that is the real problem that openEHR is solving, or FHIR, for instance. So because most people from industry, when I ask them, like, why did you decide to pick FHIR or openEHR, the answer is always exactly the same, which is, I don't want to reinvent the data models. This has already done that for me. I don't want to reinvent the stuff that they've done. I just want my data models. So to answer your question, has relational databases done the modeling of like many-to-many relationships, one-to-many? Absolutely. Like it's so easy to do this that, again, like to answer properly, you can just have foreign keys and you can have other data points and you can like relate back. So there are easy ways to do one-to-many modeling, many-to-many modeling in SQL that still respects the data anomaly principles of normalization. So the reason why we do it in SQL in that way, to me, is not just for performance. It's also to make sure that you don't have database anomalies. Like you forget to update something somewhere, right? And again, I have this problem already with openEHR. Like I have, for example, a big composition, or I have a template. Like I just want to edit one field in that particular form. But when they edit that and when they submit the whole composition back. And sometimes the app doesn't do what it's supposed to do. It deletes some information there, it adds some information. So it's already like happening. So the answer is SQL has already done this well. Like with one-to-many and many-to-many relationships, if I can show you some examples, I could, but again, like we can also talk about this later. But it's super simple to try to find dbeaver. Like all you need to do, for example, is under a form, you can have, for example, procedure screening, right? So procedure screening can have like a form ID that relates back to a form, and you can have as many procedure screenings as you want. And again, if something needs to be nested inside procedure screening, we even tackled slots and like dynamic linking. It's not that hard to do. It's just some smart modeling in SQL and you're already there. Like we were able to do that. Yes, Eric.
So, Sam Hurd.
Yes, Sam.
I think one of the first criticisms we had about openEHR from the beginning, Tom will be smiling, I'm sure, was we didn't say how to do this. So when you put something up there, it was never specified how to do this. And I can tell you the first 10 were probably took your approach, okay? But what you're really proposing, I think what we need to listen to is that technology has improved in its capability and layers on top. That's the big message. So this, if you go back in time, you'll see that many implementations took this approach initially.
No, absolutely. And I think I read a lot of papers on how people have already done that and how they have modeled that. What I noticed is the performance jump that we've had in the past few years is substantially, like, it's crazy. Like, you can do joins across hundreds of tables and break no sweat. in a normal SQL database. Whereas like in the past, people used to be like, oh, I have to join that. It's going to be like it's solved. Like it's almost night and day. Like these are different technologies what we have.
Okay. It wasn't totally clear to me if you mean that do we actually need a human to go in and do all those edits of the schemas, or is it fully automated when I upload a new template with a because it said you had to think about this and that and for this archetype, blah, blah, blah. That's probably not scalable at all. I've seen many people come to the open-air field during the years, and one of the first reactions for database people is, let's make a table for each archetype. And it's not always successful, I can tell you. And usually it's been like, if you take a tree, chop it up into small pieces when you store it, and your main use case is to show it to a user, then you have to put all those pieces together again. And now you said that that's a lot faster than it used to be. Well, nice, but you're free to do this, of course, under the hood, just like Sam said. OpenAIRE doesn't prescribe you to relational or anything else, so you're kind of knocking in open doors. People have been free to use relational databases for OpenAIRE, but many of the big ones have chosen to, if the main use case is actually to get that tree back up as a composition, it's very efficient to just store it that way and then index in smart ways. So when you say people use SQL databases, it's usually together with some clever indexing.
So I want to like throw that question back to you, right? So why is it that maintaining a schema or maintaining tables, for example, and again, like the database schema management and the CI/CD pipeline around that has come a very long way as well. Like there are now declarative tools that will automatically look at your diffs in what the schema changes are, and it will automatically generate what needs to be done. So we've come a long way in maintaining the state of a database, like in terms of schema, without data loss. Now, why would maintaining archetypes and templates versus maintaining just like schemas, like what is exactly the difference? Okay. Okay, cool. I think that's good. It's good.
Yeah. Used. You're obviously not hungry.
And the answer can't be because clinicians can use a GUI to build archetypes. Because you can use a GUI to build schemas as well.
Yeah, can you show me?
Yeah, so many schema builders out
That's
there.
why find what you want to show, and then I can make my point, and you can invalidate me. So my main message, and I like you for bringing this up because you describe a real problem. I just think that you're doing it at the expense of a bigger problem. So I think the biggest issue in healthcare we have is this huge chasm between the users, the doctors and the nurses, and the developers. It's just such broad chasm. It's really hard to understand each other. What openAIRE has done brilliantly is lowering this a little bit by making technologies that doctors, somewhat normal doctors, can use. Well, just using SQL wouldn't be feasible for any normal doctor. And I think the biggest scarcity currently is doctors understanding a bit about technology. So if you go to SQL, you will widen that. And of course, it's great to use all the standard SQL tools and all the development capacity, but you will lose the doctors. And we're back to square zero, I would say.
See, I definitely think you have a point in simplifying SQL enough. And again, I could show you like so many tools which make it easier for just like schema building. And there are even like tools where you can provide a prompt with like, okay, build me a schema for this and that. And it generates like declarative SQL. But I understand your concern about will a doctor be able to identify if that's the right schema, right? But again, in industry with openAIRE today, it's not really the doctors who are going and building the archetypes anyway. It's like clinical modelers. There's a transition layer. And to me, I think like Ian can probably build SQL as, why do you not want to? Like, what is the only thing that's stopping you from, okay, you have a definition in archetype, there is ADL, there is all of these data types. It's more or less the same thing in SQL. Like, so what's the big Just no. Yeah. But, yeah. Yeah, okay. Yeah, but the thing here is, okay, the problem with modeling certain archetypes without thinking about the normalization principles, again, like we do have that problem as well. So because you don't do this modeling upfront, and then you don't think about what will happen when, for example, something changes or when they're updating, you have all of these update anomalies, these insert anomalies, maybe some transactional anomalies, because,
Yeah.
okay.
Okay, so I'm not a techie. I, make information models, and I govern them, and I do some low-code development as well. I don't particularly care what's under the hood, as Sam pointed out. It's made to not care.
Yep.
As a specification, and I think that's possibly a good idea from my limited knowledge as a modeler and low-code implementer. What I really care about is being able to create and govern the models outside of an implementation.
Yep.
That's one thing. And also as a low-code developer, I care about being able to use a query language that doesn't require me to know a complex database schema, and that allows me to be very, very specific about all the sub contexts of a particular composition. And if that's possible to do, all those things with this method that you're describing, and it'll be more performant, that sounds amazing. I'd love to do that. But I think also, as you pointed out, it's then there needs to be this layer to be able to allow people like me who are somewhat unusual nurses, I guess, from my point of view, to do these things. Thanks.
No, absolutely. I completely agree, and I actually think the examples that you and Ian gave really did help, right? Like how the stack is modeled and how the template is modeled. But a lot of that modeling, I do think that it's possible to have tooling that's easier for clinicians. But then the output is just SQL, so that we don't have to build everything else, right? Like we stop there and then we can do what we need. I absolutely agree with that. But there is some degree of movement that the clinician also has to do, because the issues with storing data in a certain way are real. And like we probably need to think about that in some form or another, right? So, Thomas?
There's lots of things I could say, but it would take 3 hours. So the key question I would say is it's to do with representational sophistication or semantic sophistication. And where do you want the primary expression of models to be? And the models need to be as close as possible to the sort of cognitive universe of people like Cillian and people who do the models. And we will get into workflow and protocol, so workflow task-based type graph representations of clinical process as well. It's getting more sophisticated over time. So the base question is, if what you're proposing is to take all those models and just don't worry about things like ADL anymore and move into the primary representation just being SQL, at least in a database like Postgres, I mean, they're probably not all quite as capable, you're going to throw away some semantic sophistication, potentially quite a lot. And then you're going to find it's difficult if we started to add in, which you can already do, add in first order predicate logic statements into archetypes, although it isn't used very much now. Mm-hmm. That's going to be, what's that going to be transposed to stored procedures of some kind? The constraints, I think, are going to be a problem out of the box. But the bigger problem is that Postgres version of SQL isn't our language. It's not even specifically connected to our domain. So if we want to have specific semantic capabilities in our modelling language,
Yep.
we're going to either keep building our own because it's more sophisticated than anything out there, or if somebody comes along, and there are attempts out there like Shackle, S-H-A-C-L, that's a sort of close-ish, approximate attempt to do something a bit like archetypes in the W3C. Well, we might take something like that, but then there's a third party who owns the language, and you have to always think, okay, are we just going to go with that, and whatever they do, you know, we've got to send people to W3C or some other organisation and try and influence them, or else we just remain blocked.
Yep.
Or else we stay as a leader of, you know, and HR7's got smart stuff as well. Like, there's a bunch of leaders in this space. Why do we invent all our own stuff? Because the indigenous, you know, previously existing technology just doesn't solve it. So that's actually the key thing to think about. And so if you were to try and refine your argument, and I kind of like it because I like the fact that, you know, why not smush it all into Postgres and, you know, see how well you can do it. For me, I would be looking at not changing where the primary expression of the models is, having a nice Postgres, you know, it would be like SAP, right? It's like SAP. It's generate a system out of a bunch of input files. And why not? I mean, if you can make it work for certain use cases, I don't think anybody would argue against that. But if you take away the entire design universe and tooling and everything that has total freedom and semantic sophistication, I think that's going to be potentially problematic.
Yeah, so I do not disagree with you on the fact that if we simplify things down, there will be certain things that you might be able to represent in a domain-specific language much better than something like SQL, 100%. But here, this is the problem, right? Like, we don't have that much money to actually make this work, and the technology frontier is going to keep growing. And when my customers or my students come to me and they ask me, why can't I use this with this tool that I love, or why can't I just make it work with normal BI tools, I would rather tell them, okay, it's not going to be semantically there 100%, like you can't represent everything that you can in archetypes, but for 99.9% of your use cases, you will probably be able to get what you need to get done, right? And for me, that extra, maybe it's not 0.1%, maybe it's like 2%, maybe it's 5%, I don't know. But giving up on that 5% to open this up to so many more people, so many more tools, for me is a worthy compromise. And again, it's definitely a compromise. I'm not saying that you can do everything the same.
Well, look, I think it's been a pretty amazing debate, and I'm sure one that's going to continue. I'd like to thank Sidharth for being both provocative and evocative, and for the great conversation and the spirit in which it was had. Thanks, everyone.